Hey everyone, I'm going to be making you guys a video here to just walk through the problems that are in your quiz review for your quiz that is on Pi Day, of course, next Tuesday, March 14th, and I just wanted to, just give you an idea of the explanation behind the problems, as well as I know you guys have the keys in those red binders, but thought this might be of some assistance. So let's look at the work. On numbers 1 through 4 here, we are calculating the circumference or the area, whichever is indicated. And please notice that we are giving our answers in terms of pi, as it says, and I've underlined for you. So remember what that means is that we're doing all the multiplications except for times the pi key on our calculator, and it's going to be a nice clean answer of just a numerical value times the pi symbol. So depending on what you're given in the problem, we have a different formula. And remember, these formulas are going to be on the board for you for Tuesday. If we look at number 1, the value that they're indicating is 25 meters. That's my radius. So I'm going to start with the circumference formula that is in terms of the radius, which is 2 pi times r. So we have circumference times 2 pi, radius is 25, and then the circumference is 50 pi. Please don't forget to put the units at the end, since this is a measurement of length around the outside of the circle. So we are going to make that 50 pi meters. Let's look at number 2. On number 2, same idea, still finding circumference, but this time the value that they've given us, notice the measurement is placed right over the center, point H there. In that case, where you have it at the center of the circle, that is indicating that that's my diameter. So we're going to use circumference equals pi times diameter, which is another equation, another way of writing the circumference formula. And of course, that is going to be pi times 42, or 42 pi, and notice we have our inches there. Looking at number 3, this time we've switched to asking for the area. So as we look at the area, here's my formula for area. Area equals pi r squared. The value that they've given me is the radius. So we're going to put 10 into the spot for r and substitute that in. We get 100 pi, and that's yards. Number 4, the value that they've indicated in the diagram, 1,200 miles. Notice where that's labeled. That's right over the center, point R in the circle. So we need to assume that this is the diameter. And notice in my calculation for area, we need the radius. So as you can see, I've put 600 in for the radius, substituted there. And we need to square 600. So that's 360,000 times pi. And then end up with your units in miles, please. Next section of problems, we're still doing either the circumference or the radius or the diameter. We have to be careful of what it is that they're asking us for. I do not have a diagram this time, so just read really carefully, okay? As you're looking at number 8 on this page, it says, what is the diameter of a circle with a circumference of 4 pi yards? So notice I'm starting with the equation that relates the two variables that they gave me, which was diameter and circumference. I'm substituting the value 4 pi for the circumference, and then notice what happens with my pi's is that they cancel out on both sides of that equation, which is really nice. So my diameter is just 4, or 4 yards. Number 9, this time they're asking me for what is the radius when the circumference is given to me. And so I'm going to start with circumference equals 2 pi r form of that equation, of that formula, and then substituting 20 pi. Again, my pi's are going to cancel out, but this time I need to make sure I divide that result by 2 so that I get the radius by itself. And so we'll have 10 meters. For number 10, we want to know what is the radius. This time we're being given an area. This is a little tricky. Be careful here. If the radius is given, or the radius is what we need to find and the area is what's given, we're going to use our pi r squared formula for area. We're going to substitute our 25 pi in there for the area value. Again, the pi's are going to cancel out, but this time I have a quadratic equation of 25 equals r squared. And to get down from r squared to just r, I need to take the square root of both sides of the equation. When I do that, I actually technically get algebraically two answers there. Notice the plus or minus, because it's both positive or negative 5 squared that could give me 25. However, since this algebra is being done in a geometric context, just keep in mind that really only the positive value where r is greater than 0 makes sense, because you don't want to have a negative measurement. So we want to make sure we're only giving the radius of 5 as our answer, 5 inches. Moving on to the back of that page, for number 11, same type of problem. This time they're giving me the area, and they want me to come up with, here's the area of 100 pi. They want me to come up with the diameter. Now my area formula starts in terms of radius, so we're going to follow the same process that we did on problem 10, substituting 100 pi for a. My pi's on either side of the equation are going to divide out. I'm going to take the square root of 100, and remember, positive or negative, but really only the positive 10 value makes sense. Now that's my radius. Remember, I need my diameter. So I'm going to just double that to get my diameter. And we get 20 miles. Moving on, we have a word problem here for numbers 7, 8, and 9. We have a student named Stella who wants to cover a tabletop, a little art project, with nickels, dimes, or quarters. And she wants to make sure that she's using the one that is going to cost the least to use, but still cover the best amount of area for the cost. So they're going to walk us through this process in problem 7, 8, and 9. Notice what we're given are the diameters of the coins in number 7, and the first step we want to do is to find the area of each coin. Notice it says we're rounding to the nearest tenth, but I would caution you when you're using pi values to wait to round until you get to the very final step. So look below here for the work that I've done. For number 7, sorry about that. For number 7, we have our nickel, our dime, and our quarter. Oops. Our nickel, our dime, and our quarter listed here. The diameters are listed. And here's my pi r squared equations. But notice every time we're plugging in or substituting my radius, I've cut the diameter in half. So there's the 10.6, there's the 8.9, and there's the 12.25 that are being substituted in. When I square each of those, I get a value in terms of pi first. And then in my last step, I'm going to apply the times pi value in my calculator. And then each of those is going to get rounded to the nearest tenth. So notice I've placed one extra decimal point value to the right of the tenths place. So that can tell me whether I'm rounding up, which I am in this first for the nickel, or whether I'm staying at the tenths place that's already there, which I am in the case of the dime and the quarter. So there's my area values for 7. Then going back up to question 8, it says, okay, take those area values and divide them, divide the coin's value by the coin's area. Again, we're rounding to the nearest hundredth there, but we're going to wait to do that until the very last step. So you can see the setup for the work that I have there is that the value, of course, of the nickel is 5 cents, dime is 10, and quarter is 25. And what we want to see is which one of these has the largest value per unit of area, which is the square millimeter. 5 divided by 353.0, the value we came up with in number 7, gives us one more extra decimal point past where I need to round would be 0.014, so that's going to stay at 0.01. The dime is going to be 10 cents divided by the 24.8 area value we found in number 7, and that's going to be 0.040, and we're going to round that to 0.04. Then the quarter is going to be 25 divided by 471.4, and to 3 places, because we need to go one past where we need to be in the end here, we have 0.053, and because the 3 is the final digit that we're concerned with, the rounding stays at 0.05. So finally, to answer question 9, which is how is Stella going to make this table covered in the cheapest way possible, what we've determined is that the nickel has the smallest value per unit of area, and so we want to use the nickel. Let's go to the next page. This is lesson 16.3, and we're practicing with sector area here. Remember, the formula for sector area is going to be on the board for you for your quiz. So we're just basically using this formula that we did a couple classes ago to calculate the area of the sector. Please be aware that what you can see here, the way that the practice worksheet, your review worksheet, is asking you to do the forms of your answer is going to be the same as what you're going to see on the quiz. So you want to make sure you have an answer that is in terms of pi and also at the end rounded to the nearest hundredth. That's 2 decimal places, remember. This is the same practice that we had when you were in class, so shouldn't come as a shock to you. I need a simplified number in terms of pi in front of the pi symbol and also the decimal equivalent when you use your calculator. Okay, so for number 1, notice we're given the radius and we're given the angles measure. So we have the measure over 360, which gives me the fraction of the total area that I want to calculate. Substituting in 140 and 18 in those spots and then doing some arithmetic. If we reduce or simplify that front fraction, 140 over 36, that is going to simplify to 7 over 18 in its lowest terms. And then 18 squared is 324. If I go ahead and just multiply in my calculator, 7 times 324 and divide by 18, we're going to get 126 pi. That's my exact answer. Then for my approximate answer, now I'm going to stick my pi key into my calculator, and to the nearest hundredth, that would be 395.84 square millimeters. Number 2, same idea. This time the angle value that's given to you is 75 degrees with a radius of 12. Substituting in those values for m and r and reducing, simplifying that front fraction, 75 over 360 is going to simplify to 5 over 25. They both have a common factor there of not only 5 but 3, so we can divide by 15. 12 squared in front there of the pi is 144 pi, and so once I've simplified 5 over 24, I can multiply that by 144 and I just get 30 pi. Using my pi key on my calculator, I'm going to have 94.25, and that's square inches. Number 3, we've got our sector area again. They're switching us to a 10-degree angle this time with a radius of 6. Substituting those 2 values into my formula, this front fraction simplifies to just 1 over 36. 6 squared is 36. So this all simplifies to simply just 1 pi or pi. And we know that equivalent in terms of to the nearest hundredth is 3.14 feet squared. Finally, number 4, just another example here. We have 90 as my angle and 20 as my radius. Substituting those two values, 90 out of 360 is 1/4. 20 squared is 400, so a quarter of 400 is, of course, just 100, and that's 100 pi. So to the nearest hundredth, rounding, is 314.16 meters squared. Let's go to the next section of problems. Got a word problem here. Don't let that scare you. We have a speedometer needle in Ignacio's car is 2 inches long, notice. As I'm reading through this, it would make sense for that 2 inches to represent my radius, so I made a little note of that. And that the needle sweeps out a 130-degree sector, and that's my measure of my angle, so I'm going to make a note of that as well. During acceleration from 0 to 60 miles per hour, really not important information there as far as our calculation of area, so I'm going to ignore that. We just want to know the area of the sector again, and this time we're just going straight to our rounded to the nearest hundredth answer. So 130 substituted in for m, and then 2 inches substituted in for that radius. We have 13 out of 36 to simplify that front fraction times 4 pi, and the equivalent rounded is 4.54. Make sure you have your square inches at the end there. For numbers 6 and 7, these problems are a little more involved, so I wanted to kind of look through those with you. We're calculating the area of the shaded region. The shaded region, if you would be just kind of like the crust of this little wedge of pizza here. So it's hard to see. You can probably see it on your paper copies better, but when they talk about the shaded region, they're talking about just this part right outside the triangle, but still inside the circle. So in order to find that piece, we're needing to take the area of the sector, or of the pizza slice, minus the triangle itself, which is like everything except for the crust of the pizza. And then to find the area of any triangle, we had a bonus video in Module 13 that walked you through this process if you knew two sides and the angle in between those two sides. We have a formula that says the area equals 1/2 those two sides multiplied together times the sine, S-I-N, that's my trig ratio, of the value of the included angle. So that's what's going to help us to figure out these problems. Let's look at number 6 really closely here. For number 6, we're trying to find the shaded area, and so the first thing that you can see is me calculating the area just of the entire sector. That's what A sub S means. So my measure is 60 out of 360. My radius is 11. And that value comes out to be, and I'm keeping, notice, an extra decimal point place until the end of the problem. So 63.355. Let's go to 3 places there. Then that's the whole entire sector. So that's this whole thing with a rounded edge from QR, that little arc there, and then coming and drawing back to the center of P. The whole entire wedge has that area. I want to subtract out what the area of this triangle QRP is, and I'm going to use my new formula, 1/2 A times B times the sine of C, or the included angle. Well, in this case, A and B really are both 11. If it helps you to label them both, then go ahead and do that. But that's what we're looking at. A and B are 11, and the included angle, or the angle that comes between those two sides, is 60 degrees. So my calculator walks me through this calculation. I get 52.395, go to 3 places, which is the area of the triangle. Then if I just want the shaded area, remember we're only interested in this little crust piece. The shaded is the subtraction or the difference of those two values that you just came up with. So that's 63.355 minus 52.395. And my final shaded area rounded to the nearest hundredth is 10.96. Make sure you have square units there, kilometers squared. Number 7, same exact setup for that problem. We have the area of the sector that we want to find first, which is my area of a sector formula. This time we have 45 for our measure of our angle out of 360, and times pi times the radius, which in this case is 25, all squared. If we crunch through that on our calculator and get an approximation, go to 3 decimal places past, we have 245 plus 0.437 for the area of the sector. And then for the area of the triangle, we're using this new formula, 1/2 AB sine C. Again, if it helps you, notice that the two sides that are including that 45-degree angle are both the same because they're both the radius of the circle. So we have 25 times 25, and then the sine of 45 is my included angle, the measure of that sector angle again. And if we calculate that, don't forget to multiply by 1/2 in the front there, we get 220.971. Again, to calculate the shaded area, we just want to do the difference of those two values, the sector minus the triangle, and we get 24.47 square yards. Okay, moving on. Last lesson that you are going to be responsible for your quiz on Tuesday is lesson 17.1, and this is just coming up with equations of a circle. So I will remind you that the formula that we were working with for 17.1 today is this formula right here, which is x minus h all squared plus y minus k all squared equals r squared. And remember, that is where your center is the point h comma k for you. So as I'm looking at number 1, which is find the equation of the circle centered at the origin with a radius of 10, that is going to be 0, 0 for hk, and then a radius of 10 substituted in. All we really need to do is square that radius to get my 100. Notice x minus 0 and y minus 0, each of those squared. I didn't write those parentheses because that's not really as simple as you can go. For number 2, we have a circle with the center r, -1, 8, so that's my hk, as you can see right there, and the radius of 5. So what we're going to have there is, let's zoom out a little bit here, we're going to take -1, -1, and substitute that in for our h value. Remember, when that's our h, we actually have a +1 inside the parentheses, so it's x plus 1 squared. My k value is 8, so substituting that in that spot right there, we have y minus 8 all squared, and then the radius is 5, we get 25. For number 3, new center, -5 and -5, so this time we're going to have two pluses in our equation, x plus 5 all squared and y plus 5 all squared. The hardest part of this problem is figuring out what is the r squared value. So because I have a radius which is given in simplest radical form, 2 radical 5, we need to multiply 2 radical 5 times itself. So side by side, 2 radical 5 times 2 radical 5. What I'm doing there, as you can see, is I'm multiplying the parts of those expressions that are not under the radical first. I get 4. and then I'm multiplying the radical times itself. And when I square any radical, that radical disappears. So we have 4 just times the value under the radical, which is 5, and we get 20. 20 should be my r squared value in the equation. For number 4, the type of problem they give me here, we can see we have a circle centered at the origin that is passing through a point 9, -2. So we want to know what is the distance between the origin 0, 0 and 9, -2, and that's going to give me the radius, because the center at the origin gives us these two terms pretty fast, just x squared plus y squared. We're interested in what is the radius. So to find the radius, we want to do the distance formula. The distance between the origin and the point 9, -2 is what we need to find with our distance formula. So we are going to take the difference of the x's squared plus the difference of the y's squared, and when we simplify that, that comes out to be the square root of 85. So if we try to square the square root, remember, what happens is that we just get the expression under the radical, which in this case is just the number 85. So our final equation is centered at the origin x squared plus y squared and equals 85. For number 5, we're looking for the center at 0, -2 that passes through the point -6, 0. Again, we want to figure out what is the radius by doing the distance formula between those 2 points. So the difference of the x's squared plus the difference of the y's squared, and that's going to give us the square root of 40. So when we square the square root, we just get 40 itself, and the substitution of your h and your k gives you just x squared by itself, but y minus -2, y plus 2 all squared. In the next section of problems, you are being asked to graph each of the equations that you see there. Most important things to know, of course, when we're graphing are the center and the radius. So we should be able to read the center right out of the x minus h squared, y minus k squared parts of the equation, or the left-hand side. And then the radius squared is the value that's given on the right-hand side of the equation. So a quick square root from radius squared equals 25 gives me that the radius is 5 for number 6, and our center is right at the origin. For number 7, looking at our first parenthesis there, x plus 2 all squared, remember if we compare that to x minus h, that's x minus -2 all squared that we're comparing that to. So my center is actually the point -2, 1. And we're going to plot that point in the middle. And then for our radius, we are going to get, because r squared is 4, the square root of both sides yields r equals 2. And we have a north, a south, an east, and a west point basically in all 4 different directions out from the center there that we can kind of use as guides to create the circle itself. Let's see on the last page here. Number 8, same idea. Zooming in a little bit more. Our r squared, notice, is just 1 this time. So the square root of 1 is actually 1 itself. We get a tiny little radius this time. The center is the point 0, -3, because remember that's going to be y minus -3 that had yielded a plus 3 in the equation to begin with. So k is -3, my h is 0. Here's my center point, right at 0, -3, and then we're going 1 unit away in all 4 directions to create the graph. The very last problem in this review, you guys, number 9, we're going to read the center off of the equation for number 9. We're going to see that our h and our k values are just 1. So our center is 1, 1, and our r squared is 16, which has a nice square root of 4. And so we're going 1, 2, 3, 4 units above, to the right, below, and to the left to create our points that are going to guide the rest of our graph. Hopefully that was a helpful walkthrough for your quiz review packet today. Prepare for your quiz on Tuesday. I'll see you guys next time.